But it is May 3rd. It's already May, my goodness, in 2012. And my name is Luke Smith. Eric Ferriolo is off in New York right now doing a Hack Day event, so he's not with me today. So I'm sort of on my own, but I'm fairly comfortable with that because I'm just going to be talking about DataTable. It's going to be mostly sort of an ad hoc, let's play with the rendering mechanisms and stuff in JS Fiddle. And let's see, we'll talk about some of the different formatting things, formatting options, as well as some performance things that I have queued up for 3.6. Let's start with the recorded. Feel free. Pushed out a DataTable related blog post that's going to be part 1 of 2, and this one is talking about the sort of a high level of the architecture and why there was a refactor and what the general idea is behind the refactoring, which is to reuse the model classes and the app framework classes to delegate the rendering of content off to Vue instances, to Vue classes, and then a little bit about how the rendering algorithm was completely rewritten. The big thing about how the rendering algorithm was rewritten was that it was moving over to a string-based rendering. So at the end of the day, what the data table does is it looks at the columns, it evaluates your column configuration, and it builds up a template. So this is a row template, which is just HTML string with a bunch of placeholders, the typical sort of, so if I said var template equals tr and then some placeholder here, and then it's going to iterate through all of the individual columns and populate this space in here. Now it's actually getting that template. The tr template here is actually in the data tables body view instance, which is on the public API for that is table.body, and this is equal to an instance of the y.datatable.body view, which, as it happens, is configurable here. So this is actually the default, is that the body view is set to y.datatable.body view. So when render is called, an instance of this class gets created, and it fires an event. Table fires an event called render body. Let's just do this. Oh, what the heck? Anyway, so that gets to be the first mishap of the day. Fantastic. Since it's all live coding, we get to have fun like that. Maybe it's body render. I don't think so, but we'll see. Anyway. So it fires an event anyway. Maybe I should just open this up and see what happened. It fires an event, and then the default function of that event, which I believe to be render body, didn't throw any errors, so I don't know what's, the reason is subscribing to it after it's done. There we are. Here, let's try it now, shall we? Hello. Okay, so then inside of here, there's this e.view, which corresponds to that view instance. So if I said row template, let's console log that out. And there's my row template. So this is the row template as it is defined by this particular view class for the body. So if you want to customize the rendering at the really highest level, you're going to completely replace the rendering algorithm. You can specify the body view and or the header view and the footer view with different view classes and just do whatever you want to do in that. But the DataTable's rendering algorithm now creates these instances of the view classes, fires these events. So there's a render header, render body, and render footer event, and each of them is going to receive this event object, which has this e.view property, which corresponds to the instance of the view. And if you need to be mucking around with the view instance, and that is most of the configuration that you'll want to do for rendering a customization, is just something that you can do. It is supported in the columns configuration primarily. So let's get rid of that and let's start messing with the columns then. So I have just sort of a basic table set up at this point, which just has some random numbers generated inside of these. So let's talk about some of the individual column configurations that we can do. First of all, we'll specify that as keys and let's see. Let's start with the obvious, which is formatter. And formatter can be a string. So let's see, hi value. And the value corresponds to what you have in a formatter function. So if I go over to the user guide, I can see down here in the appendix, the column configurations, there's a formatter argument. So the formatter argument properties, the value, this object, well, I suppose in this case, since you're just doing a string formatter and we don't have access to other things inside of the string formatter, you're pretty much relegated with string formatters, you're pretty much relegated to value. You might be able to get away, I wonder if you can get away with class name as well. Let's just mess around here a bit. Nope, didn't think so. Okay, so then that's useful for doing, you know, your typical $sign formatting if you wanted to do $sign formatting. But if we wanted to do HTML, notice something very important here, which is the formatter by default, and actually this applies to the data itself actually, and this is something that Jay Shirley just sent in a pull request for. Thank you very much for that, by the way. But the default behavior, let's just put this back to a $sign here. Default behavior is to do HTML escaping of the values that are held in the data. The reason for that is for security. So if you have user contributing data that then gets spit out into a table, YUI takes the stance that we are secure by default and we allow you to, you know, loosen those restrictions if you want to. So in this case, the way to loosen those restrictions is to specify the allow HTML column configuration, which now makes that supported. I think actually there's like, so it is an M, it's just not, it's just being overridden, I guess. Nice. Well, that's good to know. But the HTML is now rendering as HTML in that case. So that same thing applies for whether or not you're doing it in the value itself, if the values themselves contain HTML, or if you are doing them in a formatter. So let's try it this way. href. And so now it has HTML allowed in there. Now this is a bit of a tip. If you know that your data is secure, it's handled otherwise, the data that you're displaying is going to be safe, you don't have to worry about escaping, you can pass in the allow HTML true configuration for the column anyway, and what that does is it avoids that extra call to HTML escape. The call to HTML escape is really light, you know, it's not really doing anything, and when I ran performance numbers on it, it didn't really come up in any sort of measurable way as far as impacting the rendering of table. But it all depends on how big the table is you're rendering. But if you know that the data that you're displaying is secure, one option for doing a teeny tiny little performance improvement is to pass in allow HTML into the column configuration. And that will bypass the HTML escaping of content that you know is already safe. So let's see. Another formatting related thing is empty cell value, which I'm empty, like that, and then we'll go into data, let's say 3 equals that way. Ah, look at that. Except for string formatters today. I actually just filed a bug about this on myself yesterday. Defined right now. So for string formatters today, this is only for string formatters. This doesn't apply to values by themselves. So if I just did that, it comes up with I'm empty, and null also triggers the empty cell value. And empty string also triggers the empty cell value. This holds true the or null or undefined. Those will trigger empty cell value, except if you have a string formatter, in which case only undefined will trigger the empty cell value. Today, I'm going to add support for null to string formatters in the future. I'm on the fence as to whether or not to also add support for empty string triggering empty cell values when you have a formatter string. Just because the empty string might be a valid value, and you so it's hard for me. I don't want to presume that that's not cool. So let's talk about formatter functions. Yeah, John, that's a good question. I am doing explicit checks, so 0 doesn't trigger it. So I'm not doing a falsy check. I am doing I'm explicitly looking for null or undefined or empty string. The reason for that is that 0 is a perfectly valid number to be to be formatting. So, so Juan, are you actually in here as well? I see you in. Oh, look at that. Juan's not in the Connect chat, but he is in IRC, and he's asking, since we're talking data table, how would you add a class to a row depending upon the data for each row? Let's talk about that in a little bit. We can certainly do that. So let's talk about the function, formatter function. The automatic indenting on Fiddle is going to drive me insane. So the thing about formatters to remember is you can, what you're working with is O.value by default is going to correspond to the value that was passed into the data. But you do have O.data as well, and these are going to be exactly the same. But you also have O.data.bananas. So you do have O.record, and that's going to be a reference to the model instance. But typically, if you're just displaying data, you'll just be accessing the attributes anyway. And all of the attribute values are stored in O.data anyway. So O.record is really only necessary if you want to use the API methods on that model instance for whatever reason. I typically don't recommend using O.record because if you're using the APIs of that model instance in your formatter, it seems like a really odd place to be calling some sort of API method on a model, because that suggests that there might be some mutation involved. You don't want to be you don't want to be changing things while you're painting the content. So O.data and O.value are, for the most part, the best way to get your the data that you want to populate the cell with. So we also have O.className. Let's see, my class. And O.rowClass. Now, O.rowClass I added in 3.5 because a lot of folks wanted to use the TD node, the actual cell node, in order to get to the row, or they wanted to use O.tr, which was the 3.4.1 thing, so that they could add a class to the TR. There was the 80% rule for wanting to access the row was to add a class to the row. So my other class here, and those are strings, and if we just get rid of that, run this. So let's see here. Hello. No. In the iframe. Oh, come on. Being so difficult. Anyway, so what you would see is that the classes that were assigned to this TD cell and the classes that were assigned to the TR would now have my class added onto it and my other class added onto it. I really want that to show. What the heck? There we go. Hey, look at that. Okay, so here we have TD class, apples, cell, and my class was added on. And the TR got this additional class, my other class. So if you want to do any styling for the row, then you can do that in a formatter. And I really recommend using formatters for doing that sort of thing. The other option, of course, is to use node formatters. And node formatters exist specifically to address that edge case or the edge cases where you have to have access to the TD. or you have to have access to the DOM structure itself to do something inside of that cell. There are few use cases that warrant this under most cases. I mean, most of the time you're going to be rendering a table that's going to look pretty uniform. It's going to have columns and rows. There's not going to be anything special. So the node formatters, you know what, before we continue to node format, one last point about formatters, and that is you can set the value and not return anything, and you get new value, or you can return new value, or if you say o.value equals return new value, the return wins. So the formatter, what's happening is DataTable is looking for the return value of the formatter function, and if it's undefined, then it'll look at the O value. It'll look at that value property and see if there's something in there. Find, I get value 1. So you have the option of either when more than one column has a row class. So that's why you would want to use the plus equals. It is actually going to aggregate those on there. So key bananas. All right, so let's see, we run this here. Here we have my other class, which was added by that first column, and foo class, which is added by the second column. So you can count the number of times the format. Right.
Counting the number of times the formatter was called. That was just me being silly about it.
Oh, I see.
Do something nasty with the record inside the formatter.
Okay, gotcha. Okay, so then, as I was talking about, so the formatter, you can either return something or you can set O value and not return anything. You do have access to the classes, you have access to the row class, and you have access to all of the data in the record without going through any of the record APIs. You also have access to O.column should you need it, which is just the column configuration object. And let's say O.value is, let's do this. O.column.key. We have apples. Anyway, so now on to node formatter.
What's the context object for the formatters?
I forget. That's a good question. I know that I thought about it, but that was so long ago, it seems like. So it looks like this is, yeah, footer config, header config. So this is the data table instance. So the formatter and node formatter. Let's see, actually, this is equal to table. Right? True. So the formatter is executed from the context of the data table. You, of course, can override that by doing a y.bind if you want to. But I think it makes reasonable sense to have the formatter default to that, so that this is the data table. Feel free to disagree if you like to. So node formatters. Node formatters, they're passed in an O with different properties. I do talk about that in Appendix C, so node formatter argument properties. It gets fewer things. It gets TD and cell. That distinction exists largely to honor the past. I'm sorry. Todd, that's a good question, demoing an unbound column. So that being a column that exists without a key. It doesn't actually reference any data. So I'm going to say custom column. And I can actually just say formatter is foo. Left this out. Oh. Yeah, because it doesn't honor return value or anything. Let's see. Function. So it looks like, oh, you know what? Yeah, there's another bug that I have filed against myself, that columns that don't reference a key don't pass into the string formatters today. So I have that. That's also a bug that'll be taken care of. But you can get around that obviously by passing in foo, or passing in a function formatter with a return value. Ooh, that's not what I wanted. But here, of course, you have access to all of the rest of the data. So I'll say apples in here. Data.apples. And now my apples column, which was tied to that key, apples key, is empty because I'm using a node formatter, which we'll talk about. And then the unbound column, the one that's that just uses a label, just uses a label and a formatter to output the value of the apples column. And I can do all sorts of things. O.data. That mess. Okay. So you can, in principle, get at anything about the table from inside the formatter. What do you mean by that, John? By which formatter? The formatter or the node formatter?
Context. The context object for the formatters is the data table.
Yeah. So since you have this being the data table, you of course have access to all of the data of the table.
So you can call this dot whatever you want.
Say again?
You said that you call this dot whatever, right? This is the data table.
Right. Yeah. So inside of your formatter function or inside of your node formatter function, just referencing this .sum API method, you have access to the entire state of the data table at that point. So let's talk about node formatters. So notice the node formatters, I'm returning o.column.key. O.column.key is actually, o.column is set, but the thing about node formatters is that they don't populate the cells by default. In fact, if you have a node formatter, here it is, if you have a node formatter, that the template that is generated for that row will have no value for that cell whatsoever. It'll have just the empty TD wrapper, no content inside of it. So you have, or rather the cell template is present, but that's it. So it's up to you to say o.cell.set HTML node format. And there is no concern in this case for allow HTML because you have access to the Node API directly. So if I said href. It's going to generate that markup. So node formatters have access to the Node API, which means it's entirely up to you to do what you need to do with that cell. The primary value of a node formatter is modifying the DOM structure around that cell. I tried to put as much support for getting everything you need to get done in the formatter function. And the big distinction between the formatter function and the node formatter function is that the formatter function is working with strings. There is no DOM that exists at the point that the formatter exists. When the formatter is being run, the DOM doesn't exist for this yet. This is all just building up strings. So we're generating a bunch of strings, and then after all of the items have been iterated over, all the records have been iterated over, building up that string for the entire T-body, then splat. It all goes in one execution of a, I think it's set HTML or set content. So technically, not a single node instance is created in the rendering process of the T-body, at least anyway. So that ends up having a huge performance impact because in 3.4.1, a large part of the slowdown was that it was creating a node instance for every cell, for every liner div, for every TR, and it was working with those APIs explicitly. And when you create a node instance, it gets created and stored into a node cache so that later if you access that node, you'll get the same instance of node that you first encountered. So you can actually do a triple equals check against, y.1 pound foo and y.1 pound foo later. They have to be equal. So Node has to cache those references in order to support that triple equals check. But that's going to consume a lot of memory. If you're drawing out a really big table, you don't actually care about those nodes except for the life of when you're populating that content. So the move to the string-based rendering alleviates that by not creating any node instances whatsoever, and just so it doesn't populate the node cache with a bunch of instances. So it's not consuming memory. It's just working with strings, and it ends up going into inner HTML after the appropriate HTML escaping, like I'd mentioned, for individual cells. So it ends up being really fast. Node formatter exists if you have to be working with those nodes. But since you have to be working with those nodes, that means that on this O object there is a cell property and there is a there's a TD property which reference node instances. That means that there is now a node instance that was created for this cell. There's only a node instance created for that cell, not for all of the rest of the cells in the row. So it's just for the cell that exists for that node formatter. But that cell is now in the node cache. So you can use and send store. You can use the Node API to then class, let's see, bar class, and then o.cell set HTML. And if we run that, we have my inner HTML, and hopefully it'll update. Does it update? No, it's not doing it. So let's try it again. So string rendering is also faster because setting inner HTML is faster than repeated document to create element, right? That is true of older browsers. Actually, today the time difference between inner HTML and document.createElement and actually working directly with the DOM is kind of a wash, and in some browsers I believe DOM creation is a little bit faster because the rendering engine, I think it's WebKit in particular, has been optimized to support doing lots and lots of DOM creation operations. And so it's able to batch those in a really efficient way. But the difference between really, really fast and really, really fast -1, nah. We went with string-based rendering because it is really, really fast in the older browsers as well. So anymore, it can be, you can go either way, either pure DOM or inner HTML strings. Let's try this again. Inspect element. There we are. So now I have the TR is getting the bar class added because I'm doing that through the Node API, through the TR, and adding class. However, now I have created this a node instance for the TD and a node instance for the TR because I had to create a node instance to support o.cell.ancestor. So so if I'm not working with Ancestor, let's say I'm just doing this o.cell, etc. HTML, and I'm doing a lot of special munging in the cell content for whatever reason. I have to use the Node API for that. If I don't actually need the Node instance around at this point, I just needed the Node API for the process of rendering the content. I don't need that Node API around anymore, or that Node instance around anymore. Node formatters do support a return value, but the return value is explicitly false. And at least I think it's false. It's either false or true. I say so in the documentation. Let me check that out. Node formatters. But what that does, what the return value does, is it then calls destroy. Let's see, node formatter function. Let's see, O is return false. Right, so yeah, do that. So what returning false does is it destroys that node instance, but it's only destroying it in the cache. So if you have, well, it's destroying it in the cache, and it's also removing any event subscriptions that you have on it. So if you're just using the Node API for creating that content, then you should return false unless there's some compelling reason to keep the node in the cache. You shouldn't be creating event subscriptions individually per node. You should be using event delegation for that for two reasons. One is that it's more efficient, and two, because any sort of mutation of the data in the data table is going to cause the table to refresh. It's going to re-render. And so unless you have the cleanup logic in place for those subscriptions and for those nodes, potentially all of that's just getting wiped out and replaced, and new subscriptions are coming in, and that's just increasing memory bloat, right? So return false from node formatters and use them as sparingly as possible. And let's see, Todd, you had a question about if a node formatter is used, if the record is deleted, does it delete the TD node that was created? If a node format, let's see. If the record is deleted, then that record being deleted is going to trigger a table re-render. So that entire row is then going to go away in response to that mutation event. So not just the individual cell. Oh, does the TD node that was created go away? No, I don't believe it does. That is a good question, though. It will clean up the node instances sooner or later, but depending upon what sort of operations you had going on in that node formatter, there might be some reference counting that is going to prevent it from getting GC'd. So it's best to be really explicit with your cleanup, and that's why node formatter has that return false support, and why node formatters in general aren't recommended. So if a node formatter is used, if the record is deleted, does it delete the TD node that was created? Oh, here we go. Let's see. So GC doesn't still use ref count. It depends on the browser. There's ref counting and there's mark and sweep, right? And I think it depends on which browser you're in. Let's see. GC will clean up node instances from the previous table render. That's the hope, right? But so let's go on to we just have a few minutes left, and I really want to get into the performance stuff. One other thing that I want to talk about for formatting is cell template. So I am going to do something a little funny here. I am going to say I'm going to get rid of this node formatter here. So I get rid of all of that stuff. And I'm going to say cell template. Content TD. That. And now I will go TD call span. This is completely an experiment, by the way. Content. Space in like that. Now let's see what happens. Check that out. So here what I've done is for this specific column, I've added, I've said instead of using the default cell template, which is just a TD with the appropriate classes added, that sort of thing, I'm using this cell template, and since this is all string-based rendering, I'm now composing a string for this row that consists of this string template with the value substituted into here, but I didn't close the TD. In here I didn't open a TD, but I did close it. I added a call span here, and since this is all string-based rendering, I'm not using any node formatters at this point. Actually, if you use node formatters, it'd still be fine anyway. But so I'm doing a call span. It is a little sneaky. It's kind of gimmicky, if you will. But okay, so there are so many other little things that I want to cover about formatting and things, but let's talk about performance. So the string-based rendering makes the render process really fast, much faster than 341. We're talking like 1,000 rows in Chrome 18. 1,000 rows rendering used to take about 480 milliseconds. And, 480 milliseconds, it's Chrome. It does stuff fast, but 480 milliseconds, that's pretty slow, right? For Chrome, for rendering out 1,000 rows. So in 350, the rendering process for 1,000 row in Chrome 18 takes about 80 milliseconds, right? So there's huge improvement. So there's 400 to 80 or 480 to 80. So rendering out 1,000 rows takes basically no time in modern browsers, and it goes significantly faster in older browsers as well, as in to the point where 1,000 rows, rendering out 1,000 rows, won't completely lock up your UI. But the things that you have to keep in mind for rendering are that in 350, I didn't have time to incorporate mutation optimization. So when you modify the data, it re-renders the entire table. Fortunately, the rendering algorithm is fast, so that it doesn't hurt that much. But if you have a lot of mutations going on, then for each mutation, it's going to potentially re-render the table. So if you're going through every row and modifying something in every row, then that's re-rendering the table every time, and so that's 80 milliseconds added on to, in Chrome, this is like best case scenario, 80 milliseconds added on to each individual item of work. So if you wanted to do, so let's see, table.data.each function model. model.set apples, new apples. This is going to be slow because for each one of those, I'm re-rendering the entire table. This problem is going to go away in 3.6 because I do have the mutation optimization code, you know, proof of concepted out. I just need to refine it and get it into the source. But one way to avoid this sort of thing is to pass in an additional argument, silent true. And what that does is it silences the mutation events from the model, which are then going to bubble up to the view and cause the table to re-render. But that means that I'm now updating the table, or I'm updating the data, but I'm not updating the table, right? So I don't have my new apples thing. But follow that up with sync UI, and it'll make things go a lot faster. So now I get new apples in there. So that's one way to help performance when you're doing a lot of table mutation. I have a variety of gists that I will link to in the blog post since we're running out of time at this point. I have one for optimizing the table mutation. I have another for creating a model class. So when you're creating the data table, you can also populate the record type. There are a couple examples of this now, thanks to Todd Smith. You can define your own model subclass here by just specifying the attributes that you want. And that's going to then generate a model subclass with these particular attributes in there. So you can do special cool things using the attribute APIs by defining a record type. But record type also accepts a full-on model subclass. But I tried very hard not to do any coupling, explicit coupling between data table and model, or data table and model list so much. There's some defaulting. The default behavior does use model and it does use model list, but it does allow you to pass in an object that quacks like a model list into data, or a class that quacks like a model class into record type. So I have a gist that shows a very simple object that quacks like a model that will avoid the overhead of doing the attribute setup and the instantiation for the model instances for each of your records. And another gist that is sort of the proof of concept that I'm going to be implementing, or I'm going to be fleshing out to implement in 3.6, which is a flyweight proxy model list, which what it does is it will compile a proxy object that is based on your record type, or based on your record type, which is defined by either default or explicitly, looking for attributes that have getters or setters. And if the attributes don't have getters or setters, or default values, or any sort of additional attribute logic, then what this proxy object does is it just quacks like a model, or it quacks like a model, I suppose. But it's also this flyweight that has the APIs that are necessary for the rendering algorithm to go through its deal. But the iteration over that model list, the special sort of model list object, when it iterates over these items, instead of actually creating an instance of model, it just uses this proxy object with that raw object data. So if you have raw object data just getting plugged into this one object, and then that object has the API that satisfies the rendering algorithm, you're now not creating any instances of anything. And so with that in place, with the proof of concept that I had in place, the instantiation time for DataTable with 1,000 rows in Chrome went from 400 milliseconds to 2. So that has an awful lot of promise, and hopefully there's always devils in the details, of course, but and it's likely it's only going to go up from there. I mean, it can't really go down from 2 milliseconds, but so I have a gist. I'll post that on the blog post, and I'm already a couple minutes over. I think I'm eating into my staff meeting, which I'm not going to cry about. But there are a couple, so there are a couple different performance optimizations, either replacing the body view with a very simple class, replacing the record type with a very simple class that quacks like a record or quacks like a model, passing in data that is not a model list but quacks like a model list that has that sort of proxy flyweight support in it, which is by far the fastest of these performance improvements, and this is the one that I'm going to be targeting for 3.6. Otherwise, there's the little thing about saying allow HTML true for cells that are for data that you know is going to be pure and doesn't need to be escaped. And we talked a little bit about the rendering mechanisms and the objects that are in place, the different classes and things like that. So I think that's going to have to do it for today. And I'll get those links to those various gists out in the blog post. And I think so. And so you know where to find me on IRC. You can add your comments, questions into the blog posts, add your comments, questions into the forum. If you come across any issues, please file tickets. And if anybody else has some last parting messages, yes, read, pagination is coming. Then with that, we will sign off, and we will talk to you guys again next week. And when we will have Eric F. back in the house, and so there will be a little bit more conversation. All right, so thanks everyone for dialing